Firstly, there are reported issues with Nikar trade name ground fault circuit interrupters. These problems include tripping without a clear reason, where the ground fault circuit interrupter trips even when there is no ground fault. Secondly, some Nikar ground fault circuit interrupters may fail to trip when a ground fault actually occurs, indicating a failure in their protective function. Thirdly, the lifespan of these ground fault circuit interrupters might be shorter than expected, causing them to fail prematurely. Placing a 15-amp ground fault circuit interrupter on a 20-amp breaker with 12-gauge wire creates a hazardous situation. The ground fault circuit interrupter is designed to trip when it detects an imbalance between the current flowing through the hot and neutral wires. If a 15-amp ground fault circuit interrupter is paired with a 20-amp breaker, the breaker may allow more current to flow than the ground fault circuit interrupter is designed to handle. This excess current can lead to the ground fault circuit interrupter overheating and potentially melting, even when there is no load connected to the circuit. Furthermore, 12-gauge wire is generally suitable for 20-amp circuits but is not typically used for 15-amp circuits. Using 12-gauge wire on a 15-amp circuit can also contribute to the overheating and melting of the ground fault circuit interrupter. It is important to adhere to the National Electrical Code guidelines to ensure electrical safety. Installing a 15-amp ground fault circuit interrupter on a 20-amp breaker with 12-gauge wire is a violation of the National Electrical Code and presents a significant fire hazard. It is essential to use ground fault circuit interrupters that are properly rated for the specific circuit on which they are installed. When selecting a ground fault circuit interrupter, ensure its amperage rating matches the circuit breaker's amperage and the wire gauge is appropriate for the circuit's amperage. For a 15-amp circuit, use a 15-amp ground fault circuit interrupter and 14-gauge wire. For a 20-amp circuit, use a 20-amp ground fault circuit interrupter and 12-gauge wire. These guidelines are provided by the National Electrical Code. Breakers protect the wire from carrying too much current and overheating, which could lead to a fire. A 20-amp breaker will allow up to 20 amps of current to flow through the circuit before tripping. A 15-amp ground fault circuit interrupter is only designed to handle up to 15 amps safely. If a fault occurs that draws more than 15 amps but less than 20 amps, the ground fault circuit interrupter will be overloaded, potentially causing it to overheat and melt, while the breaker will not trip. This is a dangerous scenario. The ground fault circuit interrupter is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing through the hot and neutral wires of a circuit. If there is a difference of more than a few milliamperes between the current flowing through the hot and neutral wires, it indicates that some current is leaking to ground, potentially through a person. The ground fault circuit interrupter will then trip, quickly cutting off the power to the circuit and preventing a dangerous electrical shock. Using the incorrect amperage rating for a ground fault circuit interrupter can compromise its ability to protect against electrical shock. It is crucial to ensure that the ground fault circuit interrupter is properly matched to the circuit's amperage to provide effective protection. Regularly inspect ground fault circuit interrupters to ensure they are functioning correctly. Test them monthly by pressing the test button on the device. If the ground fault circuit interrupter does not trip when the test button is pressed, it may be faulty and should be replaced. When installing or replacing ground fault circuit interrupters, always turn off the power to the circuit at the breaker. Follow the manufacturer's instructions carefully when wiring the ground fault circuit interrupter. Ensure that all connections are secure and that the wires are properly sized for the circuit. If you are not comfortable working with electricity, hire a qualified electrician to install or replace ground fault circuit interrupters. Working with electricity can be dangerous, and it is important to take precautions to avoid electrical shock. When selecting ground fault circuit interrupters, choose reputable brands that have a proven track record of reliability and safety. Look for ground fault circuit interrupters that are listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure they meet safety standards. Ground fault circuit interrupters are typically required in areas where electrical outlets are likely to come into contact with water, such as bathrooms, kitchens, and outdoor locations. Check local electrical codes to determine where ground fault circuit interrupters are required in a specific area. Ground fault circuit interrupters are an important safety device that can help protect people from electrical shock. It is important to use them correctly and to maintain them properly to ensure they are functioning effectively. Using a higher amperage breaker than the ground fault circuit interrupter is rated for can create a situation where an overcurrent can damage the ground fault circuit interrupter without tripping the breaker, leading to a potential fire hazard. The ground fault circuit interrupter is designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person. The ground fault circuit interrupter quickly trips the circuit when it detects a ground fault, preventing a dangerous electrical shock. The breaker is designed to protect the wiring and the circuit from overcurrents, which can occur when there is a short circuit or an overload. An overcurrent occurs when more current flows through the circuit than it is designed to handle. The breaker trips the circuit when it detects an overcurrent, preventing the wiring from overheating and potentially causing a fire. Using a 15-amp ground fault circuit interrupter on a 20-amp circuit creates a mismatch between the protection provided by the ground fault circuit interrupter and the protection provided by the breaker. The 15-amp ground fault circuit interrupter is only designed to handle 15 amps of current, while the 20-amp breaker will allow up to 20 amps of current to flow through the circuit. If a fault occurs that draws more than 15 amps but less than 20 amps, the ground fault circuit interrupter will be overloaded and may overheat or melt, but the breaker will not trip. This can create a dangerous situation where the ground fault circuit interrupter fails to protect against electrical shock or fire. It is essential to use the correct size breaker for the circuit to ensure that the wiring is protected from overcurrents. The breaker should be sized according to the ampacity of the wiring. The ampacity of a wire is the maximum amount of current that it can safely carry. The National Electrical Code provides tables that list the ampacity of different sizes of wire. For example, 14-gauge copper wire has an ampacity of 15 amps, 12-gauge copper wire has an ampacity of 20 amps, and 10-gauge copper wire has an ampacity of 30 amps. When selecting a breaker, choose a breaker that is rated for the same ampacity as the wiring. For example, if you are using 12-gauge copper wire, you should use a 20-amp breaker. It is also important to consider the load that will be connected to the circuit when selecting a breaker. The breaker should be sized to handle the total load that will be connected to the circuit. The load is the amount of current that the appliances and equipment connected to the circuit will draw. The load can be calculated by adding up the wattage of all the appliances and equipment that will be connected to the circuit and then dividing by the voltage of the circuit. For example, if you have a circuit that is connected to a 120-volt outlet and you have two 100-watt lamps connected to the circuit, the load would be 100 watts plus 100 watts / 120 volts equals 1.67 amps. In this case, you could use a 15-amp breaker because the load is less than 15 amps. However, if you added another 100-watt lamp to the circuit, the load would be 100 watts plus 100 watts plus 100 watts / 120 volts equals 2.5 amps. In this case, you would need to use a 20-amp breaker because the load is greater than 15 amps. It is always better to err on the side of caution and use a slightly larger breaker than is necessary. However, you should never use a breaker that is larger than the ampacity of the wiring. Doing so can create a dangerous situation where the wiring can overheat and potentially cause a fire. In addition to ground fault circuit interrupters and breakers, there are other safety devices that can be used to protect against electrical shock and fire. These include arc fault circuit interrupters and surge protectors. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. An arcing fault occurs when electricity jumps from one wire to another, creating a spark. Arc fault circuit interrupters can detect these sparks and trip the circuit, preventing a fire. Surge protectors are designed to protect against damage from voltage surges. A voltage surge is a sudden increase in voltage that can damage electronic equipment. Surge protectors can absorb these voltage surges and protect electronic equipment from damage. It is important to use all of these safety devices to protect against electrical shock and fire. Electrical safety is a serious matter, and it is important to take precautions to avoid electrical shock and fire. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. The National Electrical Code provides detailed guidelines for electrical installations. These guidelines cover everything from the size of the wiring to the type of breakers that should be used. It is important to follow the National Electrical Code guidelines when installing electrical wiring to ensure that the installation is safe and compliant with local codes. If you have any questions about electrical safety, consult a qualified electrician. A qualified electrician can answer your questions and help you to ensure that your electrical system is safe and compliant with local codes. Regularly inspect your electrical system to ensure that it is in good condition. Look for any signs of damage, such as cracked or frayed wires, loose connections, or corroded terminals. If you find any signs of damage, have the problem repaired by a qualified electrician. Never overload electrical outlets or circuits. Overloading an electrical outlet or circuit can cause the wiring to overheat and potentially cause a fire. Use power strips with surge protection to protect electronic equipment from voltage surges. Keep electrical cords away from water and other liquids. Water and other liquids can conduct electricity and create a shock hazard. Never use electrical appliances or equipment near water. If an electrical appliance or equipment falls into water, do not touch it. Turn off the power at the breaker and then carefully remove the appliance or equipment from the water. Have the appliance or equipment inspected by a qualified electrician before using it again. Teach children about electrical safety. Children should be taught not to play with electrical outlets or cords and to never touch electrical appliances or equipment near water. By following these safety tips, you can help to prevent electrical shock and fire. Electrical safety is a shared responsibility, and it is important for everyone to do their part to ensure that electrical systems are safe.